Okay, lesson 6-1 for honors geometry is on angles of polygons. So all the way back in chapter 1, you named and classified polygons. So now you're going to find and use the sum of the measures of the interior angles of a polygon, and you're going to find and use the sum of the measures of the exterior angles of a polygon. And you'll see the relationship between the two. So the sum of polygon angle measures. So we're going to come up with a way to derive a formula for finding the sum of the interior angles of any polygon. So how can we figure out how we can add up all the inside angles on a shape? Based on the fact that we know the sum of the angles of a triangle is 180 degrees. So we're going to start off small. So you begin by drawing a 3, 4, 5, and 6-sided convex polygons. And then what you're going to do is from one corner, one vertex, you're going to draw all the diagonals. So here's your triangle, your quadrilateral, your pentagon, your hexagon. And then from each vertex, pick one vertex, just one. And then draw in to every other opposite vertex, get your diagonals. So what I notice is my quadrilateral has 2 triangles in it. My pentagon has 3 triangles in it. My hexagon has 4 triangles in it. So let's make a chart of information. So in a triangle, I know a triangle has 3 sides, and of course that's just one triangle, and we already know that the 3 angles of a triangle add up to 180 degrees. So if I have a quadrilateral, 4 sides, 2 triangles, 2 times 180 is 360. Pentagon, 5 sides, it had 3 triangles, so 3 times 180, all the angles of a pentagon will add up to 540 degrees. 6 sides on a hexagon would make 4 triangles, so all the angles of a hexagon add up to 720 degrees. So if you just keep going, of course, a heptagon would have 5 triangles, so the angles would add up to 900. Octagon has 8 sides, it would have 6 triangles, so all the angles, 8 angles of an octagon are going to add up to 1080. A nonagon has 9 sides, so it would have 7 triangles, and it would add up to 1260 degrees. So the key to this whole problem is what's the relationship between the number of sides and the number of triangles? Well, if I have n number of sides and I wanted to get the number of triangles, it's always n minus 2. Because every one, 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. And every time we were taking the number of triangles and then we were multiplying by 180. So to get the sum of the measures of the interior angles of a triangle, it was n minus 2, and then we multiplied by 180. So that is the polygon interior angle sum. The sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. So if you knew you had a 5-sided polygon and you wanted to know what all the angles added up to, you would say, oh, well, n is 5 sides, so then 5 minus 2 is 3, and you would do 3 times 180, so you would know that all the angles in this pentagon would add up to 540 degrees. So what is the sum of the measures of the interior angles of a convex 22-sided polygon? Well, if you have 22 sides, and you would do 22 minus 2, that would tell you you could actually draw 20 triangles in that problem, and each triangle is 180 degrees. So you're really just doing 20 times 180. So 18 times 2 is 36, and then you got to add the 2 zeros on. So there's 3,600 degrees in a 22-sided polygon. And it all came from using the formula n minus 2 times 180. B. Find the measure of each interior angle of parallelogram RSTU. Well, a parallelogram has 4 sides. So if I do 4 minus 2 times 180, so there's really 2 triangles I could draw. So 2 times 180 is 360 degrees. So I know all 4 angles in a quadrilateral will add up to 360. So all I have to do is add up angle R plus angle S plus angle T plus angle U, and I know they add up to 360 degrees. So 5x plus 11x plus 5x plus 11x would be 32x. And plus 4 is 8. That equals 360. So then I would subtract 8 on each side and say 32x equals 352. Divide each side by 32. So 352 divided by 32, that goes once, with 3 left over, and that would be 11. So it looks like x equals 11. Okay, but that didn't answer my question. My question was, find the measure of each interior angle. So now I have to say 11 times 11 plus 4, so that's 121 plus 4. So I know angle S is 125 degrees. If I did 5 times 11, that's 55 degrees. So this one's also 55 degrees, and this one's also 125. So if I'm right, I should be able to add 125, 125, 55, and 55, and it better add up to 360. So this is how I check my work. So this would be 20, 2, 4, 6, and 10 is 16, and that's 360. So I know I've got it right. So the measure of angle S was 125. Measure of angle R was 55. Measure of angle T was 55. And the measure of angle U was 125. For 1A, you have to find the sum of the measures of the interior angles of a convex octagon. So pause the video and see if you can figure this one out on your own. So if you did it right, an octagon has 8 sides. So 8 minus 2 would tell you that you could actually draw 6 triangles from one vertex. Each triangle is 180. 6 times 180 is 1080. And notice over here, I shortened my multiplication. 18 times 6 is 108, and I knew I just had to put that 0 on the end. A corollary to theorem 6.1 is the measure of each interior angle of a regular n-gon. Notice regular, that means all the angles and all the sides are congruent to each other. So it's still the same formula. N minus 2 times 180 would give you the total sum of all the angles. So if you divided by how many sides you had, which is equal to the number of angles you have, then you would get each individual angle. So you want to find the measure of each interior angle of a regular pentagon. So if I'm going to do a regular pentagon, a pentagon has 5 sides. So 5 minus 2 means I could draw 3 triangles from one vertex. So 3 times 180 is 540. But then there's 5 sides, or 5 angles. So then I would divide by 5, and then that would give me 108. So actually this whole problem up here, I could have just started from right here and said I'm going to divide by 5. Great. The measure of an interior angle of a regular polygon is 150 degrees. Find the number of sides in the polygon. Well, I can use that same formula for the interior angle sum theorem to find the number of sides. So if I know every angle is 150 degrees, then I could figure out the sum of those angles by taking 150 times the number of angles. So n represents the number of sides as well as the number of angles, because those are always equal to each other. And that would equal to 180 times n minus 2. So I can distribute the 180 and get 180n minus 360. Then I can subtract 180n on each side. 150n minus 180n is a negative 30n, and that would equal a negative 360. Then I could divide each side by a negative 30, and I would get n to be a positive 12. So I know there's 12 sides on a polygon when each angle, a regular polygon, when each angle is 150 degrees. This is a lesson investigation on the exterior angles of a polygon. So if you would draw a convex quadrilateral and extend the sides to form one exterior angle at each vertex, then cut out the exterior angles and tape them together as shown at the left, what can you conclude from this result? So this is what you're going to get when you cut out those 4 angles. You get a circle there in the center. So what is the sum of the exterior angles of a convex quadrilateral? Well, the sum of the degrees of a circle is 360 degrees. So let me show you what this looks like with something maybe more than just a quadrilateral. So this is a pretty cool applet to show you the exterior angle sum theorem. So we're trying to figure out the sum of these angles, and I can just click some points and I can make a polygon. So I'm going to make more than just a quadrilateral. So 1, 2, 3, 4, finish it up, there's 5. So I've got a pentagon. So if I scale down my pentagon, and I just keep scaling it down and scaling it down, what shape am I going to get? I'm going to get down to a circle, which is 360 degrees. I can do it again with something bigger. 4, 5, 6, 7, 8. So there's an octagon. If I scale it down, every time I scale down the exterior angles, they come together to form a circle. So that's why all the outside angles on the polygon are always going to add up to 360 degrees. So this leads you to the polygon exterior angle sum theorem, which says the sum of the exterior angle measures of a convex polygon, one angle at each vertex, is 360 degrees. So if I would add up all these outside angles on that polygon, all 6 of them are going to add up to 360. And it doesn't matter if I have a hexagon, a heptagon, an octagon, whatever. Okay, they're always going to add up to 360 degrees. So a corollary to that theorem is the measure of each exterior angle of